Hi, I'm Francisco Campor, and this is Just for Fun from Brazil. Welcome to episode number 24 of Just for Fun. Today we're going to be talking about scanners, parsers, ASTs, and all of the things that basically allow you to analyze a program. Specifically, we're going to be analyzing Go programs, but the same idea could be used for basically anything. So what we're going to be doing is we're going to try to extract information from a given program, actually from any Go program, and see where are the limits of the different things. What can we extract given a scanner? What can we extract given a parser? And what other things we could use to extract more things. Does that sound fun? Let's get started. Cool, so the first thing we need to know is what is a scanner? What is a parser? And what are other things? Just to give you a basic idea, a scanner is something that generates tokens. So when you give it a program, like for instance, a program that says package main, func main, func.println hello world, something like that, what it's going to give you back is a series of tokens. The first token is a package token. Then it's an identifier token with the value main, this package main. Then it's a func token. Every single keyword is a different token. Punctuations are also tokens, but also you get things like identifiers or numbers or strings and stuff like that, which are different kind of tokens with string values for them. Then we can parse. So that is what a scanner is. Then we have parsers. And what a parser does is actually it uses a scanner most of the time in order to generate structure from those things. And it uses what we call a language grammar. In Go, the language grammar is actually specified in the Go specification that you can go check out. It's a pretty easy to read document. I'm not going to say you should all read it right now, but if you have time, why not? It's an interesting document to read and not too hard to understand, which is good. And basically it says things like, well, a function definition starts with a func token, then a name, then parentheses, and in between all of the parameters, and then maybe parentheses, maybe not, and all of the results we're returning. This is a rule that we consider part of the grammar that allows the parser, given a bunch of tokens, extract a structure, and that structure is a tree. And that tree, we call it the abstract syntax tree, AST. And ASTs are something that are very powerful and allow you to understand a program from a better point of view than just tokens. So what we're going to do is we're going to start using first a scanner to try to extract all of the identifiers, all of them that we can find in a Go program. And then we'll use a parser to try to identify what kind of identifiers we have. So we can say, actually, I'm just interested on the function names, or I'm just interested on the type names, etc. That sound fun? Let's get started. Okay, so let's start creating a new directory I'm gonna call scanner, and let's write some code. So in my scanner, I'm gonna create a main.go. Let's make it bigger already. And what we're gonna be doing is, okay, so what we need to do is we need to scan a file. To do that, we need two things. We need a file and a scanner. So rather than scanning a file only, I'm going to scan many files at the same time. So what I'm going to do is I'm going to use os.args, the arguments from the OS, as a way to get all of the paths that I should be working with. So if the len of os.args is less than 2, that means that we only have 1, which is the name of the program itself. So we can do fprintln to standard error and say usage, the name, and then files. And then, so that going to pass os.args. And you can guarantee that os.args always has one element, which is the name of the binary. So this is acceptable to do. And then exit. So, okay, so now you print f always. So if I do go to scanner and do go build, when I run the scanner, say you should use scanner files. Cool. And if I do scanner foo, then it doesn't complain. Cool. So now what I want to do is for arg in OS args of all of the arguments except for the first one. We're going to just print the argument for now. So let's see. Go build. Scanner foo bar, foo on bar. Cool. So now what we're gonna do is we actually going to do something like foo.go, bar.go, etc. So those are the files. So how do we scan something? So we need a scanner. So scanner.scanner var s, and that is a scanner from the Go scanner package in the standard library that provides a scanner of Go programs, quite obviously. So now that we have it, we can do s.init. And when we initialize it, we need to pass a file from the token package, the code of the program, and an error handler and a mode. So let's start with the token file, with the token.file. So for that, we're gonna start with a new file set, and this will provide a way to group all of the files that we're parsing. And then we're gonna do the file is gonna be fs.addFile. The name of the file is gonna be that argument. The base is going to be the base, which is how many lines we've read so far, basically. And then the size, it's going to be some size that we still don't know, because we also need the contents of the file, so we need to read that too. So I'm gonna do, I need to read file of args. If we cannot read it, let's do, log fatal error. Because if not able to read it, then it should just fail. I think that's fair. Otherwise, so that's gonna be the number of bytes in the file is how many bytes we read. We get that file. We need to pass that content there, and the error handler, that's if we're not able to parse something, what should we do? I'm gonna say we're gonna ignore it, because it's not really that important. You could pass a function there, and then every single time that there's a problem scanning a file, it will print that message there. Like it will call that function, and then you could print or do something else. And the mode for scanning is going to be, so scanner dot scan comments or not. Let's scan the comments too. Okay. And now we can do s.scan. And when we do s.scan, that returns a token. So the position of the token that parsed, the token itself, and the literal value of it. So we're gonna do that in an infinite loop. So that's gonna be pos token and lit. It's gonna be that. And if the token is token.eof and no file, then we'll just break that loop. Otherwise, we will print post doc and lit. This is not happy. Yeah, this is happy now. Cool. So with this, now we have our, whoops. With this, we have our program. We make sure that we're passing at least an argument. And then what we do is we create a file set, and for every file we read it, we create a token file, and then we scan it. And for every scanner, for every token that we read, we will just parse it. We will just print it, sorry. So if I do go build, go build, and then I do scanner, main.go, there you go. Now we're getting for every single, so let's go to the beginning. Ooh, there's a lot here. Okay. So you can see that the first one is package, and that is there's that package. Then we have an identifier, which is main. Then we have a semicolon, and this is interesting because this is where the Go scanner will add semicolons automatically. So you can basically think that Go has those semicolons written. The parser doesn't care about this anymore because they're being added automatically by the scanner, which is kind of cool, but you don't really care about. The only interesting thing basically is that you will be able to see them all of the time, and you don't really care that much about them. So you have for an import, and then you have here that parenthesis, that's another token. Then you have a token which is of kind string that has the value thumped, and the value go scanner, go token, etc. Then the func main here, you can see that there's a func. There's an identifier of type main. Then there's open parenthesis, close parenthesis, open brace. So that is exactly what we would expect. And that's pretty much it. We have not done any deeper analysis. We just figure out what is this thing here piece by piece, right? So os.stdr, you will be able to see it somewhere around here, where there's os, there's a dot, and there's stdr. We do not know what it is, if there's a file or whatever. We don't even know if this might be a function call. We do not know anything at this point. We just know that there's an identifier, a dot, and another identifier. That's it. That's what scanner does. So now, what can we do with this? Well, we could do something quite cool, like actually I only care about the identifiers. So if the talk is as token dot identifier, then print the literal. Let's say that this is the only thing we care about, and I don't care about the position anymore. So now when I run it, I get only the identifiers. So now I could count them, and I could count what is the most common identifier in this program. So let's do that. I'm gonna say counts is a map of strings to integers, and every single time we see a literal, we increase that. Then once we're done with all of this, we should print the whole thing. Now I want to print it ordered by how many times it appeared. So I'm going to define a new struct that has a string and a number. So pairs is going to be a slice of pairs that is empty but has the capacity of the map. And then for k, so let's call it for sn on range of counts. So we're gonna go over all of the pairs that we found, and we're going to say pairs equals append pairs of sn. This is not happy. Pairs is not a type. Pairs append pairs. Oh, pairs of pair. So we're appending a new pair to the list of pairs. And then now we need to sort them. So we can do sort.slice pairs by this function. So we're gonna return pairs of I dot n is bigger than pairs of j dot n. And then we're gonna print the top 5 for I equals 0, I smaller than length of pairs, and I is more than 5, I plus plus, println, printf. Let's print how many times it appeared and then the string itself. So I'm gonna say that the number is gonna have the capacity up to 6 digits. That's a lot, but should be okay. And we're going to print pairs of I dot n, pairs dot I dot s. Cool. Let's try it. So if I build a program and I run it, we see that the most used program is pairs. The most used identifier in my program here is pairs, which appears 9 times. Now, what can we do? Well, what if we wanted to know what is the most common identifier in the Go standard library? Is that something we can do? Well, actually, yeah, and it's very simple. So I'm just gonna say, analyze all of the Go programs and give me the 5 most used ones. And this should be quite fast. There you go, boom, done. So we have the identifier V appears 82,000 times. Okay, cool. What else can we do with this? Well, we can not do much more than that, because we could say, for instance, I only care about the ones that are longer than 3 letters. For instance, that's actually pretty simple. The only thing you need to do is basically go here and say if len of s is more than 3, then do this. Actually, it's 3 or more. So now we should be able to see something slightly different. We're gonna see that error is actually the most common one, that is 3 characters or more. Then we have args, nil, which is not surprising, true, and odd arg. Cool. So now imagine that you wanted to do something slightly more complex, like saying, yeah, sure, this is nice, but I do not care about how many times we are using those identifiers. I care about how many times we're declaring them. So for instance, let's say how many times is the type, I don't know, reader, a type named reader being defined everywhere in the standard library. Well, to do that, you actually need to have more context, right? So you could technically use the scanner and be like, well, if the item that I see right here is, so the identifier that I see right here is coming right after type token or var token or any of those tokens, then I can say this is declaring a type or a variable or a constant or whatever like that. And that's a way of doing it, but there's a much better way, which is actually getting the structure of the program and saying every single time I have a function declaration or a type declaration, give me the name of that declaration. In order to do that, the scanner is not enough. We need to move into the parser. But we will need to wait for that until the next episode, where we will learn how to use the Go parser to extract ASTs, abstract syntax trees, from a Go program and analyze it using things like what are the name of the declarations for functions, types, variables, etc. Until then, please subscribe, tell all of your friends about justforfunc, and thanks for watching. See you all in 2 weeks.